Okay, so now here we have something like we have three different types of OS. Okay, when you say operating systems, you will have some specific things related to it. Like if you say you have something like user space as well as kernel space, and again this OS is divided into three types of OS. We can say generally we see embedded OS, then we have mobile OS, and then we have real-time OS. Okay, real-time OS is nothing but your RTOS. Okay. And when you say mobile OS, one of the OS which we are using is Android, right? Android is again a Linux system.
No.
Android is nothing but Linux. And then you have embedded OS. Embedded OS does have some specific requirement again, like you will have some small amount of RAM and ROM. You will have to fit your OS in it, so the specific requirements changes. So here, whatever the type of OS is, whether it is embedded OS, mobile OS, or RTOS, your OS is divided into two halves, which is user space as well as kernel space. Okay, so we will be seeing Linux kernel here. User space are the mobile are any specific applications. Any applications which are like if you say you are using anything, you can say even what this Chrome or Adobe Reader. All these are specific applications. Okay, and underneath this, whatever process is going on, that is your kernel space. Okay, so now if you see an operating system, it consists of a set of programs. OS is nothing but a set of programs. Okay, what does this particular OS do? It manages your hardware and provides an environment. What to do the applications, whatever we are running the application, so it is providing an environment to run those applications. Again, these applications are nothing but programs only. So already a set of programs is given and we are running our programs on top of it. So your hardware, as it is managing your hardware includes your CPU, memory, input output, controllers, everything. Here we will see now, if you see, you are able to see an image, right?
Yeah.
So this is your Linux kernel architecture. Here what, if you see this, hardware includes here CPU, RAM, hard disk, various terminal equipments, network adapters. Now your various terminal equipments can be anything from keyboard, mouse, or USB, anything. Next, coming to your user space, the last one is your hardware, and here is the application tools. Application tools include, as I said, all the applications. It can be anything from code, photos, shops, anything. And if you say mobile, you do have some specific applications like your anything, games, or Ola, Uber, all these applications are running on Uber space. Okay, this user space. And next you have here kernel space. Now, what is the functionality of this kernel? So, kernel is your core. You can say core of your OS is your kernel.
Okay.
What does it do? It supports your hardware, or it interacts with the hardware. You cannot, our applications directly cannot support or cannot interact with your hardware. Now, I am writing one program to take an input from your keyboard. When you are writing programs or when you are accessing a Notepad++, when you are opening that application, directly that application cannot interact with your hardware. It does need some internal applications to just access everything. So your kernel comes in between. So your kernel just is the core and it interacts with the hardware. Now, when the first program, now this is the kernel is the first program which is loaded into your system, or it is this is loaded when you start the OS, and it will run till the TV shut down our system.
Okay.
Okay. Again, this is not BIOS. Kernel is not BIOS. BIOS comes with hardware. Now, even if you don't have OS, one blue screen appears. That is your BIOS system. That BIOS. So that BIOS is different from kernel again.
Okay.
This kernel is software dependent because this comes as a OS. Now, here you have some particular types of OS. One is your monolithic OS as well as micro OS. When you OS, all the OS things like Linux kernel, all the whatever components are there, everything comes under as a single module. You call that as monolithic kernel, and which is like a single file. Now, if you say Linux, when you have installed it in your working system, you have downloaded only one single file like Linux ubuntu.iso. Right. When you installed virtual Linux in your virtual box, you have downloaded only one particular ISO file.
Yeah.
So your Linux is monolithic software, and it is available as single file. Now, what happens when you have this single? The advantage of this is it has the functioning is very faster.
Okay.
Okay. Then you say micro OS are isolated. All the components of the particular OS are isolated, and they run in their own address space. Now, what is this? We will see later. Okay. Now, when you say, okay, one thing we have is like device drivers are there, programs are there, or any other services which is related to kernel or user space or hardware is there. Everything comes in one package in monolithic, but here in micro it will come as different packages. Okay, but the good thing about this micro OS will be the size will be less when compared to monolithic. Okay, now if you see this particular image, you can see that here you have what is the function of kernel now. If you understood till here the thing is when kernel is, you can say, one program which is interacting in between you and your hardware. Okay, now what is the function of this? Here the function of your Linux kernel is process management, memory management, file system, device drivers and networks. Okay, now these are the basic components which we will be seeing in our further classes. So what is this all these things do? We will see one after the other. And what does this support? Now, here if you see one simple application I'll say, here what happens when you are writing one application. Now, if you write one C program, what do you need? You need your keyboard to write your program. When you are writing your program in an application Notepad++, so you have opened a Notepad++ application and you want to write it. Now, when you want to write it, what you will have to do is you will have to use a device driver. Okay. Why you need a device driver? Why? Because you are using a keyboard.
Okay.
So one particular device driver will be there for one particular hardware. Each hardware will have will have one device driver. So that device driver uses that application. Now, if you remember microcontroller, when you want to connect an external device, you are using UART.
Yeah.
Right? Now, when I'm using here You are even here you are using UART, but do you know you are using UART? No, you don't know. When you are using keyboards, you don't know you might be using UART because you are not seeing any internal architecture of your CPU. But who knows that? Your device driver knows that. Device driver uses that particular UART application. The UART application is implemented through your device driver, and then that is interacted through hardware. Okay, so your applications which are in user space cannot interact with hardware directly. So we are using one kernel space program. So here we are using a kernel space program. Here we are using that kernel space program like device drivers, and we are interacting with your hardware. Okay. Now, if you want, as I said, you will have two spaces. So we are dividing now in two spaces. Here the system calls and all. Okay, I'll say you about system calls. So before that, here when whatever is there at this Linux kernel, all this is kernel space, and your application is user space, and the last one is your hardware. Okay. Now, here you have a here you have one more thing. Now, if I want to initiate an input output, okay, your device driver can't do that. Your kernel cannot do that. Okay, right. Why? Because if I want to have an application, either I will have to say that, or your hardware has to say that. Okay. Now, if I want an application, my kernel don't know that I want an application. I want to open a Notepad++. My kernel doesn't know that.
Yes.
I will have to say that. That means what? Either your input-output request can be initiated by user.
Yeah.
I want to send some input and I want to get some output. So that thing either I can initiate or your hardware can initiate. Now, how can hardware initiate an IO request? It can initiate using interrupts.
Yes.
Right.
Yeah.
It can have. Now, suppose you will have. Okay. So now, it can have something like any interrupt you can get. You say your mobile. You have an interrupt like calls.
Yes.
So your hardware receives that interrupt and you are getting that. But your kernel cannot do that. Kernel will not have that power to initiate an IO, either your hardware or user space.
Yeah.
Each and everything just have a now here you can have the main thing you will have is device driver. Now we can have only one single device driver for each component or each hardware component. Each hardware component, whatever we are connecting, we will have to declare that. Declare in the sense we will have to write a device driver for that. Now only one device driver can be written for one hardware. You cannot have multiple device drivers for same hardware. Now if we are connecting keyboard, if I connect, I have 2 or 3 USB ports. If I connect to 2 or 3 keyboards, 3 different types of device drivers won't be installed. Only one device driver is there for keyboard, and that is there. That's it.
Okay.
Okay. So, but you can have multiple devices which use the same device driver. We cannot have multiple devices for multiple device drivers for same device, but we can have same device driver working on multiple devices. For example, now I have, if you say in our user space, I have an application running. What is that application? I might be using Maps, Google Maps. Okay. At the same time, I'm using Uber and Ola app. That means all these three apps, Uber, Ola, as well as your Google Maps, all these three are using GPS,
Yes.
right? They are
Yeah.
using GPS to have the location. So we
Yes.
are using GPS for the same. Now we have only one GPS in our mobile. We are
Yes.
using it on three applications, but we are using only one device, and that for that one GPS device, we have only one driver, GPS
Yes.
module driver.
Yes.
Okay, but even though we have one GPS mobile driver, we are using it on multiple applications.
Yes.
Okay, so this is you let me. When coming to here again, coming back, what does this project management do? Okay, so the work of this, so if we see, it is divided into 5: process management, memory management, file systems, device drivers, and networks. Now coming to your process management, here we can see that it is mainly used for multitasking. Process management is for multitasking. So on a brief, so here the functionalities will be: create a process, load the executables code into your process, then you will have scheduling, and then we have, it has to wait till the process end and then exiting the process.
Yes.
Okay, so basically your tasks include creating, loading, scheduling, waiting, and exiting. So
Oh.
process management will take care of this. Now,
Okay.
your tasks, your process are architecture specific codes. Okay. Now, for example, if you are writing some programs for your 8051, and you can't run it, right? We do have this multitasking, or simple terms I'm saying, you cannot have this Linux kernel on 8051. Just for example, I'm saying, why? Because I'm okay, so depending on your architecture, the multitasking or the processing services will actually, process management will have same work, but the code will be architecture specific. Whatever applications we are writing, that will be architecture specific.
Okay.
Okay, next coming to your memory management. So here, what does memory management do? Memory management will also have some particular, when you say memory management, we are using something like dynamic memory allocation using MLOC free,
Yeah.
right? So that will be taken care by. Allocate the dynamic memory, free the dynamic memory. If you are using some devices, then map that particular device to that files. All this
Yeah.
work will be done by memory management function.
Yeah.
Next, you have files or directories. Now, here each and every program or each and everything is called file directories, files. Okay, everything is a file in Linux. We will see
Yeah.
that now. So here everything is working as a files only. So you have different types of files here, and that is again divided in not divided, actually. Here you have what are the file services. Okay, types of file systems we will see, but what will be the function of this file systems are like opening already existing file or creating a new file, writing data into file, reading data from file, deleting a file. Then you will have, if you want to modify the file, or if you want to open a specific directory, Then if you want to create a new directory, delete a new directory, close the directory or close the file, all these will be done by your file systems.
No.
Okay. So all this basically we use to write some programs.
No.
All that will be coming under taken care by your file systems.
No.
Right. Next what we have is if you say here you have block devices, then you can say it as something like okay. You have one more thing you will have now. Input output services. Input output services again. When you are saying input output, they are also treated like files only in Linux. Input outputs are also treated like files. So using file services, we will be doing our input output services like opening an input output device, reading like if you are writing from keyboard, it has to read it, or if you want to write on your screen, you are using the right input output device. Okay, then we have settings. Then if you want to modify the settings or if you want to close the device, all this comes under input output devices, and they are also treated like files only. Okay. Next you have some more network protocols or network drivers and device drivers. Now here if you say device drivers, for each and every device you will have to write a driver. Basically, we are just saying we are writing or we are specifying your microcontroller, or if you say, even if you say your CPU, you will have a microprocessor, right? So you are just saying that which input output has to be used, where you are connected. Now, on a larger scale, I am saying, if you say microcontroller, so we have some input output pins. So if you see 8051, if we are even connecting your LEDs and switches, we are just saying your device or LCD. Okay, how we are not saying it directly, but we are writing our program in such a way that it will understand that this thing has been connected to this particular device or input output. Basically, it doesn't know what is that input output, but we are just making one thing zero, right? So on a larger scale, if we write each and every device will have one program, and that program we are calling it as device driver. Okay. Next, you will have some more network communication. Now coming to your network communication, what you will have in this. So in network communication, what you will be seeing is creating a network communication. You will have something like software. So creating that, then if you want to establish, obviously if you want to have network communication, you will have to establish a connection. Then we have to send the data, read the data, modify the attributes. Then if you are then closing the communication or socket. So all these things will be done under your network communication services. Along with this, we will have some other functionalities also, like we will have multi-threading services, signal services, IPC services. IPC services are inter-process communication. So that we will be seeing, and then we'll have time services. All these we will be seeing one by one in this particular module. Okay. Now, what is the structure of your directory? We have to see the directory structure. Here it uses something like tree structure or hierarchy structure. I'll just download that image because it's difficult to draw that actually. It's not difficult to draw actually, but using this either whiteboard or paint, it's difficult to use. It is like a tree structure. So when you say a tree structure, here you will have one top directory, which we are calling it as root. Okay, and then yeah, and save it, don't save it, 1 minute. Yeah, you're able to see this, right? Image.
Yes, yes.
Okay. Now if you see here, you will have, this is a tree-like structure. This is a tree-like structure. Here, this slash is nothing but the top directory, and we call it as root directory. Okay. Now under this root, we have different directories again. So this is your parent directory, and all these are again your child directories. Okay. Now what are these things? I just say you. Now in this, if you see, you have this bin directory, boot directory, dev directory, etc. Then home, root, run, sbin, temp, user, variable, and then again in home you will have alias, bob, keep. Then in this user, if you have in users we will have bin, local, sbin, temp. Now all these things we will have. Just a brief description of it I will give you. When we will write our programs, we will come to know, or we will see. Now when you are writing device drivers, we will be seeing some of the other directories. Okay, because even though if we explain all the directories right now, you will not remember anything, but a brief description I will give you. Now when you say here bin, what does this bin do is, this folder contains low-level system utilities. Okay, so here you will have some programs related to which are very near to your hardware, low-level things. Okay, this is root directory, which is parent directory. So you have you will have user. User is nothing but you will have even when you log on your Windows system, you will have some particular user application users, right? Other than guests. You have guest, you have user 1, user 2. So you'll have some users. Then in that again we have in you 1 second. Okay, in boot you will have boot related things. That means when startup is there, so at that time booting is nothing but starting of an application. So boot will have all that related files. Okay, and dev will have hardware devices. What are the hardware devices connected to it? So all that information regarding that hardware will be there in this dev, which is device. Okay, next you have etc. etc is like system configuration and information. Now when we go for your Windows, simply by clicking your you will have something like if you want to see the system information, you will just go to you will have some thing like properties, and if we go to our property and all, we will be able to see our system information. Not exactly properties, but you will have to use something like when we in Windows, when you go to PC, there you will have system properties. Okay, when you go to file, you will have system properties, and you click on it, you will be able to see all the system related information like device name, processor, how much RAM is there, what is the device ID, what is the product ID, what is it touch or not, and then if you have any OS on it, you will have all this OS, what is the screen size, everything will be there with your system requirements, right? Similarly, when you want to know the system information of our device, that will be there in your etc. Next, you have home. Now, what is home content? Home content user directories. Now, we have written some C programs, right? So we kept it on our desktop. If you remember, we have kept everything on our desktop. We created one folder, and in that we had even one recycle bin also. So all that are under home directory. Okay, but this directory will change with each user. That means some folder, now I have one folder and you are using the same system, so your files might be different. So at that time, here your home will be different for different users. Okay, my files are not visible to you. It is user specific. Okay, next root as I discussed, this is this is your parent directory. Next, you will have something like one more. If you say simple, so or whatever your temporary system or temporary files, when you are creating some applications or when you are writing some applications, there are some temporary files will be created. So all the temporary files will be there in this temp folder. Then you have user, right? In user again you have this bin. Now this bin is different from this, right? Here in child you have one bin. Again in user, here you have another bin. Now user bin contains libraries which are there for high level user program. This contains low level utility. Then high level this is for high level program. Libraries is contained. Okay. Next you have even actually you will have some files are missing here. It will have library folder also. So here it will have some collection of you will have here system calls. So all those system calls program libraries will be there in library. Then you have SBIN here. Here this is SBIN. SBIN is like you have some utilities related to hardware as well as some utilities related to the user binaries. Here SBIN is super user utility program. This will be the super user. Like super user can be any administrator, system administrator.
Yeah.
So the some functionalities are given only to that, so that all related to that functionalities will be there in information regarding that. So
Okay.
and then you will have some PROC also, and this else overview is nothing but just the folder names which we have in home directory. So this is your directory structure. What will have now? Hmm, if I want to have some information about our files, now we are saying these many files are there, right?
Okay.
So what if just a second, I'll just start this. So related to each file or folder, how will be the permission and what will be the some commands, what will be the commands we will use, so that we will see one after the other when we are writing. But if you want to see, I want to see one file, now how it is running, or um, what are the permissions given to that, we will see just with the command, single command that I will show you. I'll just share one minute. Now, here you will have one more thing. Now, till that is turning on, and just to say you one more thing. Here, if you are writing one application which is using one service of your kernel, which is suppose process management. Okay. If you are using suppose a process management, then that process management, or you can say the kernel subsystem. Okay. Now I am saying process management, memory management, file management, device, and network as some subsystems of your kernel. Okay. So
Yeah.
one subsystem can use other subsystems. Now I am writing a program to write one process or one using process management. When you are writing a program using process management, you will have to use the memory management service, because if I am using MLOps, I will have to use memory management subsystem, right? And that too,
Yeah.
if I am writing some file, opening the file and all, then you will have to use file management subsystem.
Yes.
And in that, if you are using network, TCP, IP or anything, at that time network management subsystem will come in picture. So
Okay.
one subsystem can use or they can send a request to use some other subsystem.
Yeah.
Okay. Mm. Now you have one function, for example, MLOps. Okay. MLOps directly cannot use your memory management subsystem again.
Sure.
So that will have to be, if you are writing a program in using this MLOps, you will have to use this process management, and then directly also again we cannot use. You will have to use kernel space for that. Okay. That means what? If you are using a library function, internally again we will have to use one more function or one more call. Okay, that interface in between our program and kernel is CI, system call interface. Okay, So what does this do? It acts as an interface between your kernel and your, again in between this kernel. Okay, whatever image we are seeing about your user space as well as kernel, in between that again you will have one thin layer, that is your system call interface.
Sure.
What does this do? This is function. This is performing something like it is acting again an interface between your programs and or user space and your kernel space.
Yes.
Okay, it might be somewhat confusing, but once we start writing some programs or anything, you will understand. Okay, now for example, when you are using this malloc. Okay, we are using malloc in our linked list and all. So when you are using this malloc function, what happens? You are directly not writing into kernel, but internally we are simply using malloc function, right? But when malloc program is written, that program for malloc uses a system call called brk or sprk. brk or sprk.
Okay.
SBR. Internally it is using BRK or SBRK subscription. Okay, then this SRK, BRK or SBRK send request to the kernel. Okay, similarly when you have printf function you are using or scanf function you are using, this printf function uses write function. Internally it uses a system call called write. Scanf function uses a system call called read. Then these write and read functions interact with the kernel space.
Yep.
Okay. You're able to see Ubuntu, right?
Yes.
Yes. Now, if you see this file, see, this is my home directory. In home, I have something like UC, trash.
Yes.
And when you open this particular thing here at Windows, you have something like my computer. In my computer, you will be having some C drive, B drive, A drive.
Yeah.
Is it audible or connection lost?
I think a little bit it got break. Hello.
It's audible, right? Yeah, it's audible.
Yeah.
Connection, I think, network. So here, if you see, in home you have something like desktop, documents, downloads, music, pictures, public template, videos. Okay. When you say inside this home directory, we have desktop. In desktop, we have something like C.
Yes.
Comes under your home directory. Go to other locations. Here, your other location is your computer. Okay. When you click on this, now you can see you have these files, these directories that bin, boot, CD-ROM, devices, each 64-bit, 32-bit, libraries, then home, media, which devices are mounted on it, like USB or anything. Then you have this these are also some files related to interface with kernel. Then you have system files. So all these are your folders which we have. Now coming to your permissions. Okay, one more thing related to terminal now. Here, what is this terminal actually? Here we have something called we have shell. Okay, now what is that shell is? Shell is a program which interacts with the kernel. This terminal which is a program which is interacting with kernel. Okay, now this is acting like, here we are writing some in a command and it is executing.
Okay.
Writing some commands and it is executing. Right. So this is acting like an interface between our commands and your kernel.
Okay.
We call it as command interpreter because you are just conveying that what I want to execute. You are not running, you are just writing a command and clicking on it. So it is interpreting whatever commands or executing the commands which you are writing.
Okay.
So we are writing a command that it will convey to your kernel and it will execute it. This is a shell. Okay, this is also one program and we have different types of shells. Like we have simple shell, bash shell, K shell, C shell, SS shell, all these will be there. If you want to use a particular type of shell, you have to write it as a command. Okay, now if I want to see what are the different types of shells available, or if I want to say now whatever shell we are using right now, what is the type of shell we are using, simply we have to type echo. This is also one command. Okay, whatever commands we are write, so whatever all these things we write, they are not like commands. So here we are saying that echo. We have to use $sign $shell. Okay, so this will say that here it is in bash. If you see, the shells are in binary bash folder. In this bin, bash folder contains this shell.
Okay.
Okay, now this particular shell is in this particular directory, it is safe. If we want to see, now if I want to just have something like, I want to use some different shell, at that time what we can do is, so we will write it SSH, which is secure shell. SSH is not found here. So first we will see what are the shells we have, available shells. So we will have to go to this particular bash folder or shells folder. So we will just use this command called cat etc shells. No, it is space. Okay, we'll just use this list command to see what is there in this bin folder. So if we see this, here is your bin folder. files. So here these are all the files which we have in this bin folder. If you just a second, I'm seeing our shell things here. So here you have SSH. It is secure shell. Next you have
Hello, Vinay.
actually we should have one.
Hello, Vinay.
Okay, so here the particular shell folder is not there.
We don't
So we don't have a particular shell folder, but we may have different shells. So we may have bash, ASH also. ASH. Okay, here we can next. So here we don't have this, no problem. Next we have bash. Okay. CD space backpack is go to the previous folder we are using or previous directory we are using. So here actually this should change, but here it is not changing. If we simply write here shell okay. So here the problem is we have some particular shells available, and now if this we are using the CSH is your C shell. So as you don't have that C shell, we have to install that. If you see this, okay. So if we install, then that particular shell will be available. So right now we don't have the C shell, and that's why we are not able to find it. So depending on what shell we want, here we can just install that. So here the install, here if you see this, you will have some commands. You are just concatenating or some, you are just adding some commands to it. So these are all different commands. So if you say sudo is nothing but you are giving administrative rights to it. When you want to change something into your system, you will have to say that I am administrator. That you can say using sudo. If you have apt application, what you want to do is install which application CSH. Once you type that, then that will be installed in your system.
Okay.
Okay. So here actually this is the most time I write this. I don't know. Actually, I think there are no shells, any shells available in this. We will have to install it. But so here it is. I have just given a slash without saying. So here, if you see this, okay. So here we are just here cat is nothing but concatenate. Okay, concatenate is nothing but add. So Here, if we use this cat, we will be able to use multiple files. We are just saying that we want to use multiple services using this cat. So here we are using this. So cat, etc. and shells. Here, if you say these are the particular shells available for you. sh, bash, shell, r bash, dash. All these are nothing but different types of shells available for writing your program.
Oh.
If you have heard somewhere something about shell scripting also, I think you might have heard that is related to your shell. Now coming to your commands, I will just show you what are the permissions given to one particular file. Okay, so if we say list, generally list is the particular thing we have seen in that pin. Sorry, diagram. Because when you will have some particular directories at starting, and this is that starting directory, boot, etc, library 32, all these things are there. Now, what I want to do is, I want to see more information about this. I've just used ls. ls is to list the folder, list the folders present in current directory. Okay, so we are if you see current directory, what I mean is if you are going into if you say Windows, in Windows what you will have current directory is nothing but basically you will be in C drive when you are running your system or on desktop. But when you go to D drive or E drive, you will be saying that I am in D drive or E drive. So here at starting you will be in this. But when you change it to home, at that time we will have desktop or something. Okay. So here if we say CD is to change directory to home, and then list. If you see here, you will have something like I am the user. Okay. So we say, and now if we say list, then in this particular user, this is my I am user, and when I list at starting we have desktop documents. These are the available directories for me.
Yeah. Yes.
Okay. CD, when you write it with 2 dots, you will come up back of one directory.
Yeah.
Okay. Now I want to just have some permissions to it. What are the permissions given? So if we want to look after that, so simply say I am using a command called -l. Okay. Now if we see that here all the informations will be given about these are the directories which we have. Right side is the directory which we have. So for this particular directories, what are the information given will be everything is will be given like this. Now if you see here, this is my boot, right? So boot is the name of the directory which I have, and 1412 is nothing but the date, July 17th. That's what it is. The time when it was used or created, date and time. And next you have what is the size of the directory. Next, parent, who is the parent, or what it is the part of, who is the owner, and then you have how many this particular directory, how many other folders or how many directories it is linking, that will be saying 4. And here this is like ER, RW, XR, what are all these things are nothing but what are the permissions given to this directory. Okay, if you say here something like R is nothing but read. Okay, then D is nothing but sorry, R W. W is for write, X is for execute. Okay, then here you are writing minus, right? Minus is for take away the permission, and add is for adding the permission.
Okay.
Okay, and if you have some, you might be seeing equal to also somewhere. We may find here we are not able to see any what plus sign also and equal to sign, but equal to sign is for assigning the permission and minus is for subtracting the permission. Then X is for execute, already I said. Next, you might be having some other things like one minute. This is for okay. So these are the permissions given to our file. Now if we see same thing, we will see with our file. Okay. So which we have now. If we go to our file here, please space desktop. We'll try. Actually, it is in home. So first we will have to go to home, and then in home, and we can concatenate commands as well as folders here. So
Okay.
it is slash desktop slash C. No, we don't have this folder. I don't know what are the folders present. Desktop is also not there. Oh, sorry. I'm user. First, I'll have to shift it to user. Now I will have my desktop file. Yes. Now if we see here what are the permissions given to our own folder, or we can say what are the permissions given to our C drive, we can just find out like list hyphen L hyphen was the command, right? Yes. See, here you have total of 8 files in it. It is showing. Actually, we have more. No, on desktop, sorry. Not in this folder, particularly C drive, C folder, but on desktop, we have somewhere around 8 files, and in that we have one folder called C folder as well as new folder. Okay, and in this we have some all these things like we have been assigned this particular memory, what the size of the folder is allocated by default. I think it can grow. Next, the date it was created, time it was created, the name of the folder, and who is the owner as well as your use. Okay, so we can see the permission. We can just find out the details about it. Now, if you see here, you have something like as we have seen RW, RW, XR, all these things are there, right?
Yeah.
What is this then? If you see previously also you have something like, just a second, I'll just show it. You have, if you are seeing here, you will have some minus, 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 right?
Yeah.
Okay. So what is all these things? It represents something like digit. Okay. You will have, actually it is making it like an 8-bit thing. So here you will have some digits for this. Like if you say hyphen, 3 hyphens, it just say you it represents B. Okay, so the permissions can be specified in this particular way.
Okay.
Now, suppose you have something like if I want to create a permission. Okay, one more thing we have not discussed it is D. We are saying RW, XR and all these things. So hyphen represents a regular file. D represents your directory.
Okay.
Okay. Then we have some other, already we have seen this RW, R is for read, W is for write, X is for execute, read, W, then other than this. If you have something like U, it might be user. If it is for